recording. Nearly forgot. And I know I'm not on mute because Sarah can hear me. So that's good. And all right. So we're going to wrap up conditional probability. We'll do a little bit of review. And then we've got the quiz, which you can write. It'll be available at 8 on Friday. So quiz number 1. It will be available on Friday at 8 until Sunday at, I always do this. I always mix up like how I write my times. 11:59. There, I'll be consistent. So just make sure that you have 50 minutes. And what I want you to do, I think I talked about it. I want you to submit your written work. It's just as like just in case, you know, an answer didn't get submitted properly or something like that, then I have a record of what you submitted. So it's not for marks or anything. It's just a record of what you did. And so submit your written work. And depending on what your setup is, like I work on my iPad, and so I would probably just save it as a PDF and upload that to Moodle. But if you're working on paper, which is more likely, then I just have a scanning app on my phone. You can just scan it and upload it. And if you need help, then let me know. But submit your written work within 10 minutes. 10 minutes of submitting your quiz. So I'll just check to make sure that you didn't take, 4 hours to submit your written work, because then, you've got this amazing written work and that's not the point, right? So just practice scanning if you haven't done it, but I suspect that you guys have had to do that already. And so but if you need help, let me know. There is a built-in scanning app. I think you guys we're all iPhones, I think. Yeah, so there is a built-in scanning app with an iPhone, but I don't like it. And so I like Scannable. Scannable is free. And so Scannable, but it only works for iPhone, but it is really good. Scannable for iPhone. So what I did, I just downloaded a bunch of the free ones, like Adobe Scan, Cam Scanner. There's like all these free ones, but the one that I liked the best is Scannable, but I guess it's only iPhone. But it'll prompt you to set up an Evernote account, but you don't have to. You can like bypass it. So don't be scared, because I don't have Evernote. Well, I do, but I don't use it.
Today's quiz too, we need to upload the...
Yeah, for the one that's this weekend. Oh no, I can set up a practice Dropbox if you guys want like a practice one, so you can kind of see how it is to upload work. But just for the quizzes, that's when you're submitting your work. Yeah. And it's really just like an insurance policy. Like I'm not checking it or anything unless I see that an answer is missing. Then I'll open up your written work and see if you had something there. And then if you did, then I can. It's okay. Yeah, often I'm like, what's going on here? Yeah. 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 So yeah, so it's okay, but it's just if something's missing, then like you'll be able to see if there's an answer missing and you had it. And then, I mean, it doesn't happen very often, but it does happen. So then if you look at your work and you're like, oh shoot, I actually did that question, but I forgot to write something or something, then you can send me, let me know and I'll go fix it and I'll give you marks. Okay. So Yeah. I should write a note to myself, but hopefully I'll remember. I'll set up a practice Dropbox just in case, just so you can kind of go through the motion. Okay, so we talked about conditional probability. So in terms of review, and we got way further than in my other class. So we're just going to finish conditional probability, and then that's good. We're not going to go any deeper today. And the quiz will be up to and including conditional probability. So up to the end of today. And I posted, I know there's always so much like stuff I feel like I need to tell you. Assignments 3 and 4, they're little short ones. So assignments 3 and 4 are posted and they're on probability. So just kind of defining probability, which was the first section, and then conditional probability is separate, just to give you good practice. And all the assignments are good practice for the quizzes. I often take questions from the assignments and put them on the quiz. So it'll be different numbers, but if you've practiced them.
So just to make clear, the quizzes are the things that we divided for the midterm.
That's right. Yeah. So we're gonna have 4 quizzes instead of 2 big tests. So we're gonna do like little chunks, and I think it's 40%, so 10% each. And roughly, so for it is timed, so you only have 50 minutes to do it. So the idea is going to be, you can use our class time from 8 to 8:50, and then make sure you give yourself the 10 minutes to upload your work. So you'll need 60 minutes carved out. But I mean, usually it's a lot faster than that, but I just don't want you to feel it's timed, but you shouldn't be terribly rushed, right? And it's open book. So if you've worked on assignments and you've had like kind of tricky assignment questions, you can kind of flip to that. And so like be ready with all your stuff, right? All your stuff. Okay, so assignments 3 and 4 are posted. They're not due until I want to say Tuesday, so February 8th and February 10th. But they are good practice for the quizzes. I just didn't want to push you guys too hard, like to kind of work to that 100% on the assignments, but at least if you've kind of worked on them, then and will be good practice for the quiz.
So midterm quiz will be until today.
Say that again.
So it will cover the material until today.
Yes. Yeah. Up to and including today. Okay, so for review, and like so it opens Friday morning, but then you're going to have until Sunday at midnight. So just make sure you carve out an hour at some point. Easier said than done. So for conditional probability, which we started, conditional probability, we introduced the formula sheet as well. So I'll bring in it's not the formula sheet, it's a formula sheet that I use for a different course that covers the same material, except we go a little bit deeper later on. But it's nice to have like a jumping off point if you're kind of making your own formula sheet and you want to have, what would I usually have on here, then it's kind of a nice jumping off point. So it's not tailored for us, but it does have everything that we need. And well, not everything, but that's later. Okay, so we talked about general, just probabilities have to be between 0 and 1. The sum of all possible outcomes, the probabilities have to add to 1. We talked about the complement of an event. So kind of that event not happening, and the probability is 1 minus the probability of it happening. Fair enough. We talked about the general addition rule, and the special case where if A and B are disjoint, then the probability of A and B must be 0, right? That's the definition of being disjoint, means they can never happen together. So the probability that they happen together is 0. And then we kind of skipped ahead. We skipped to the independent definition, but then I put it at the bottom. And the reason for that is because if I ask you to solve for the probability of A and B, then most people tend to gravitate towards this formula, but be careful, right? Because this formula only works if A and B are independent. Okay, and so unless it says A and B are independent, we can't use this formula to find the probability of A and B. Then we have to use something like this, right? So that's why I have them this way on the formula sheet, even though we introduce it this way. So it's really just if A and B are independent, and I want to put like kind of stars around there, kind of caution. Oh, and I totally have a ton of these printouts, and I should have brought them, but I can grab them after class, and can, if you want like a printout of the formula sheet. I have other printouts too, but only like they're scattered everywhere. It's been like 2 years since I was back in my office, so now I'm back in my office, and I'm like, oh, weird, all this paper everywhere. Okay, so then we talked about conditional probabilities. So here, this is for conditional probability. It's okay. If you feel like you're behind, you've got time to get caught up, and maybe that's good about doing the quizzes. It's like, okay, I gotta do this. I gotta get it done. But I totally get it. I totally get it. But I'm gonna pretend that we're all there. How about that? And well, Sarah and I, we talked about that too. It's like, well, did you? I personally wouldn't have watched the video, but she's like, no, not yet. I'm like, that's okay. It's okay. So conditional probability, notice that this formula, so the probability of A given B, so how we read this vertical bar is given. So the probability of A given B means, okay, the probability of A happening knowing that B has already happened, right? And so when we talk about conditional probabilities, we're talking about the probability of A depends on whether B has happened or not, right? And so that's what makes it conditional. And so how we find this, even though it looks confusing in the beginning, I just kind of read across. And so we take the probability of A and B happening together. So then this becomes the probability of A and B. And then given that B has already happened, so that's going to be in the denominator. So over the probability of B. So that's this first formula. And I typically, I don't know about you guys, but I actually prefer to have as few formulas as possible. So I would probably just ignore the second formula because it's the same one rewritten. But then I know there are lots of students who want to have it all kind of rewritten and derived in different ways. So that's why it's on here. But if you want to ignore the second one, because what's the second one? Well, it's just this formula solved for the probability of A and B, right? And so here I'll say solve for the probability of A and B. Well, then how do I solve for the probability of A and B? I would just have to multiply the probability of B over to the left-hand side, right? And so then what I get is I get the probability of A given B times the probability of B, right? Which is this formula here. So if we think back to what does it mean for A and B to be independent, it means that the probability of A doesn't rely on B happening or not happening, right? That's what makes them independent. So then if A and B are independent, then the probability of A given B would just be the probability of A, right? Because it doesn't care if B happened or not. Right, and so that's where we get the special case of the probability of A times the probability of B from. So here, so if A is, or A and B are independent, then the probability of A given B is just the probability of A, right? And so that's where we get that special case of the probability of A and B is the probability of A times the probability of B. But in general, we have to use this conditional probability of A given B times the probability of B. Okay. So we did do one example, but the most common setup for conditional probabilities is we have two consecutive events, right? So if it rained today, then the probability of it raining tomorrow is probably higher than if it didn't rain today, right? So then we have these conditional probabilities, and how we visualize these problems is with a tree diagram. Okay, and so I guess I went beyond review here, but let's just call that the end of our review. And so these problems are often set up as two consecutive events. We could do more than two, but we're going to focus on two. We're never going to go beyond two. So these problems are often set up as two consecutive events, which we can visualize, right? Just to kind of lay it out and solve the problem visually with a tree diagram. Yeah. Okay, sorry, Sarah. It totally kicked me out, and I don't know if you can hear me.
I can.
You can? Did you hear me that whole time, or did it clunk
It
out?
like It just cut out. So it wasn't for too long.
Oh, okay, weird, because it was connecting for a long time. So I'm like, I don't know. Okay, it seems like we're back on track. I don't know. I guess we'll see. I don't want to. How do I? Question is, can you see me still?
Yes, I can.
Nice. Okay. So important, you know. Okay, good. That's great. Let's grab this whole kit and caboodle. And so these tree diagrams, I want to introduce them with an example. Okay. So when we have these conditional probabilities, then typically, you know, something has to happen to affect the probability. And so that's when we often have these consecutive events. We can do it with independent probabilities as well, but that's kind of more basic, because then the probabilities of everything happening would just stay the same, right? And so it kind of depends on what's going on. But so for this example, we've got 13% of students earned an A on the midterm, and of those students, 47% got an A on the final. So as soon as we see these, okay, so 13% of the students in a class got an A on the midterm, and then of those 13%, right, then 47% got an A on the final. Now, that's a conditional probability because it doesn't mean that 47% of the entire class, it's 47% of that 13%, right? And so it's actually a very small percentage, right? And then 11% did not get an A on the midterm, but they got an A on the final. Yeah. So what we're going to do is we're going to visualize these. And the reason it's a tree is because we have kind of the first event, right? Or kind of the first layer, I kind of think of it. And then each branch is going to have its own set of branches for the second event. So if we and here, because we're talking about an A on the midterm and an A on the final, using an A to denote one of those wouldn't really make sense. So I'm actually going to use M to denote an A on the midterm and F, ironically, to denote an A on the final. And so, but that's up to you. You can pick, you know, whatever shorthand you want. And you can use A and B, but it might get confusing, right? So as long as you define them for yourself, then you can use whatever you want. But what I'm going to do first is I'm going to say let M mean that the student got an A on the midterm, and let F be the student got an A on the final. And usually figuring that out, so setting up what are my two events that I'm actually interested in can be very tricky. But once you have that set up, then you're kind of, okay, you're on the right path and it's going to be a little bit easier. Okay, so we've got, of course, a series of questions, but before I want to do any of that, I just want to show you in general what the tree diagram is going to look like, and then we'll kind of melt it towards this problem. And so a general tree diagram looks like this. So typically, and we can have more than 2 outcomes. We could have 3, 4, 5 outcomes, but just for example, let's just focus on, you either got an A on the midterm or you didn't, right? And then, we've got event number 1. So that's kind of your first layer. And let's let A be event number 1. So then here I have A happened or A didn't happen. Okay. With some probability. So I'm going to jot down the probability of A and the probability of not A. Okay. And then if I let B be event number 2, kind of the second layer, then if we focus on only 2 outcomes for B, and like I said, I think there's an assignment question where there's more than 2 branches. I think it's the sock color one. And so you have a drawer full of socks of different colors. And so then you would have one for each color, and it gets very big, right? So imagine if you have, let's just draw one temporarily, even 3. So now if event 2 also has 3 possibilities, then you'd have 1, 2, 3, 1, 2, 3, 1, 2, 3, and it just gets out of hand really quickly, right? You can do it, but it's going to take a little bit more concentration. So that's why I'm only going to focus on, did you get an A or did you not get an A, right? Did you get an A on the midterm? Did you not get an A on the midterm? Did you get an A on the final? Did you not get an A on the final? So if we think about, okay, I got an A on the midterm, let's say, or just event 1 happened. Okay, so then event 2 could either happen or not happen. So each of these branches get the same branches again. So now I have 1, 2, and same thing. If A didn't happen, then I go on to the next event. So for example, if it didn't rain today, well, it could rain today or it could not rain today, right? So we still have the same outcomes. So then we replicate these branches. So if I let B, and this is just in general, right? If I let B be event number 2, then either B happened or it didn't happen. Right? And then same thing here, B happened or it didn't happen. The difference here is that because we have already let A happen on this branch, then the probability that's underneath B, this B branch, is the probability of B given that A has happened, right? So we have these conditional probabilities at the end of these branches. So now this is the probability that B happened given that A happened. And then this next one is the probability that B didn't happen given that A happened. Same thing here, the probability that B happened given that A did not happen, and the probability that B didn't happen given that A did not happen. So now, if I want to know, okay, what's the probability of A happening and B happening, right? The only branch where that's going to happen is if I run down this branch. And if we go back to the probability of A and B, then, or B and A in this case, it doesn't matter, then I would multiply down the branches. So for all these branches, what we would do is we multiply down each of these branches. And I get lazy. I don't write out all these proper probabilities. Usually I just jot down what the probability is, and then I multiply down the branch, and that's the probability of A and B happening. And then the next branch is the probability of A and not B happening. And then the probability of not A and B happening, and then not A, not B happening. Okay, so at the end of all these branches, we have the probability of A and B, because I should probably write it B and A, but because it's a series of events, I'm going to write A and B. And so it's the probability of A times the probability of B and A, which is just multiplying down the branch. Multiplied down the branch.
I was just thinking of this on the basis of like a problem. How we will interpret it on the basis of problem, like 13% of students.
Okay, so yes. Should we make our example tree diagram now? The only thing I want to say is that the total probability, so once you have all of these branches multiplied down, they have to add to 1, right? Because you've considered all possible outcomes. And so the total of all these probabilities has to be 1, right? And so must add to 1. That can be tough if you're, rounding prematurely or something like that, but then you can give yourself a little bit of wiggle room, right? So they reasonably have to add to 1. So at the end of each branch, you're going to have the probability of A and not B, the probability of not A and B, and the probability of not A and not B. Right, and you just multiply down the branches. And the last thing I want to say before we do our example is if I want to know what's the probability of B happening, right, in this general example. So then if I don't care if A happened, the probability of B happening, well, B happened down this branch, right? And then notice how you end up saying, or it happened when you went down this other branch of B, right? So as soon as you say or, you're going to have to add those probabilities, right? Because it could happen down this first branch, or it could happen down this third branch, right? And so if we find ourselves saying or, ourselves saying or, we will add the probabilities. So it gets confusing because we multiplied down the branches, but notice then we're saying A and B. So as soon as we're saying and, we're multiplying, and as soon as we're saying or, we add. So in terms of our problem here, if we go back to our problem, 13% of students earned an A on the midterm. Okay. And so, and the wording here is a little bit weird. Let me just grab just the chunk that we need on this fresh page here. Because to me, it's not, to me, it's not obvious that this 11% is a conditional probability, but we know if 13% of students got an A on the midterm, then we know, well, now I can't do math, but yeah, math, I don't know. 87?
Yeah.
100 minus 13, right? So then I know that 87% didn't get an A on the midterm. So I already know that branch. And so even when I read this 11% did not get an A on the midterm, I know that's not that first branch. That must be the conditional probability. So then what this is going to look like, right? We've already defined M is going to be the A on the midterm and F is going to be the A on the final. So if I build a tree diagram here, then I'm going to have, I wrote the midterm and I either got an A on the midterm or I didn't get an A on the midterm, and that's a possibility, right? And those are all the possible options. Now notice if you talked about an A on the midterm, a B on the midterm, a C on the midterm, whatever, then you would have branches for each of those, right? But we're going to focus on either an A or not A. And so what we said was the probability. So notice how I get really sloppy. I don't write the probability of M is 0.13. I just write 0.13 and move on. So then 0.87 didn't get an A on the midterm. And so here for the next set of branches, and I try to give myself lots of room, but sometimes it gets a little crammed. So of the students, so of those who got an A on the midterm, 47% got an A on the final. So then here I have F, which was 0.47, which means that how many of those, it's 53, I think. Yeah, so 0.53 didn't get an A on the final. Oops, I forgot my complement. Sometimes I'll do a little, just like a little prime instead of the complement. So if you want to do prime, that's totally fine. But it's not the derivative. Okay, so then here for the 11% information, so 11% did not get an A on the midterm, but got an A on the final. And so here we're kind of assuming that what's given is that they didn't get an A on the midterm, but they got an A on the final. So then here I have either they got an A on the final or they did not. And what we're told is that 0.11 got an A on the final, and then which means that, oops, 100 minus 11, 89% or 0.89 didn't get an A on the final of those who didn't get an A on the midterm. So all these second branches are all conditional probabilities. So now at the end of each branch, usually what I like to do is I get really sloppy and I don't write out the probability of M, oops, pointer. The probability of M and F is this.
Maybe I'm a little bit confused in the statement. Is it like 11% of the whole class didn't get A on midterm? Is it like
No,
11% of those who didn't get?
yeah, so that's what's tricky about the wording here is because I already know how many didn't get an A on the midterm. And so here, how I'm reading this is that 11% did not get an A on the midterm, but got an A on the final. And so what I'm reading this as is given that they didn't get an A on the midterm, they got an A on the final, which is, it's tricky. And I mean, that's the assumption that I'm making when I read these. And so, yeah, sometimes you kind of have to take a leap of faith and say, okay, well, I know the probability of them not getting an A on the midterm. I already know that it's 0.87. So then what this must mean is, okay, the probability of getting an A on the final, given that they didn't get an A on the midterm, must be 0.11. Right, and so here I'll jot that down. Probability of F given not A is 0.11. Or sorry, A M. There. But a little bit sneaky, right? And I think for the one on the assignment and the quiz, they're not as sneaky, hopefully. So when you read that one, it should be clear. This one we're doing together, so it's like, here's how sneaky it can be. But okay, so oh yeah, so what I usually do is I get bored of writing, but at the end of each branch, I just write the combination. So here I have MF, here I have M not F, here I have not MF, and here I have not M not F. And that's just a reminder to myself so that I can only focus on the bottom of the branches later on if I need to. Because now I have a summary. Okay, well, M happened here, M happened here, right? Or F happened here and F happened here. And so it depends on what the question is.
Just a little bit.
Uh-huh.
But when we are said to build a tree diagram with an example, probably focusing on the like fancy writing that we did.
No,
Diagram, or
it's just to help you solve the problem.
we
So
are making like this. Right?
yeah,
Okay.
just like this. Yeah, I get really sloppy. And so technically what we should be writing is all of this, but I don't do that. I just write it like this. And then what I'll do is sometimes I'll write out the first one. So the probability of MF. Notice how I'm not writing M and F, because for me, shorthand MF is M and F, right? Which can get confusing. Usually I'll only write it out for the first one just to show that, hey, this is the probability going down the branch. And then I just write the total probabilities at the end of each branch. So if I go 0.13 times 0.47, then I have, and I'm going to try to keep all my decimal places because it's only 4 decimal places that it gave me. So I'm going to keep all of those. Remember, it has to add to 1. So the more you can keep, the better. And then what we're going to do is to get the probabilities at the end of each branch, you just multiply down the branches. So I'm going to do that. So 0.13 times 0.53 is 0.0689. So this is usually how I end up writing it, is just with the probabilities at the end, and I don't even explain myself.
If you're like losing the last digit, you're not getting the 1.
Yeah. Yeah. So then you would have to kind of either remind yourself, oh, it's okay that I'm not adding to 1 because I rounded.
Should be like 0.9
Right.
and something.
Yeah. Yeah. So, but you should just always check to make sure that you're reasonably, and then you remember if you rounded or not. Right. So, and then, but all of these are working out to 4 decimal places. So I'm going to keep all of them. Finally, 0.87 times 0.89 puts me at 0.7743. Right, and so if I add these all up, 0.0957 plus 0.0689 plus 0.0611, it does equal 1. Okay, so you always want to do that little check, because otherwise you've forgotten some option. Right. Okay, so build a tree diagram. We did that, labeling all the appropriate probabilities. What I mean by that is labeling all of the branches as well as the ends of the branches. Okay, let's see here. I think I have it. Oh, grab the next. Oops. What's the probability of a student earning an A on both the midterm and the final, right? So then if I look at all these branches, there's only one branch where that happens, right? So they had to get an A on the midterm and on the final. So what's the probability of both of those happening? 0.0611. So what we're going to find is once we've set up our tree, all these questions are just gonna, like setting up the tree is the hardest part. And then we're gonna be able to just use the tree to find the answers. So then we have the probability of M, or sorry, I'll write it out properly. F and M, and maybe, yeah. I know, I don't like switching the order. M and F. I'm trying to make it match the formula sheet, but I think it's okay. You guys get it. It's the probability of M times the probability of M, or sorry, F given M. Right.
I always forgot about that one. Given.
Yeah, yeah, because this is the conditional probability, right? And really, you don't have to write this out. This part is optional. That's just me emphasizing what we're doing, but then that's going to be 0.13 times 0.47, and even this you don't have to write out because you've already shown it in the tree. So if you just went straight from here to here, that's good, right? But I want you to try to write out what it is you're solving for. But if you just wrote 0.0611, that is totally fine. Okay. So what's the probability of a student earning at least one A on either, did I move it too far out here? Totally. So as soon as you see at least one, there's going to be a little bit of rejigging involved. Okay? And so what I'm going to do is I'm actually going to steal this tree again so that we can, so I'm just going to cheat and copy it again. And I'm not going to write this out. I'm not going to have this here. There. So what we do and how I use this tree is, okay, at least one A on either the midterm or the final. So what I do is I highlight down, okay, so here, this first branch, I got an A on the midterm. So both of the next branches, I have at least one A. In fact, here, down the first branch, I have two A's, right? But that's at least one A, so that satisfies it. So it's this branch or this branch, or if I didn't get an A on the midterm, in order to get at least one A, I have to get an A on the final in order to satisfy that criteria, right? And so here, or that. So as soon as I'm saying or, and then I'm saying or this branch, then I'm going to have the probability of at least one A, and you can just write it out in words. It's really hard to write that out in symbolically, so I just write it out in words, and that's fine, is going to be, and again, I'm going to write it out properly, and then I'll just show you where you can jump to. So the probability of M and F plus the probability of M and not F plus the probability of not M and F.
So it's like totally fine if we are doing like this. You don't have to go to the fancy writing like that.
No.
I'm having a little bit difficult.
Yeah, so the fancy writing is not really that helpful. Like, as if you understand the tree, you'll be able to solve these problems. And that's why we use the tree, is because it's meant to make it easier, because then you're like, okay, this branch does it, this branch does it, right? So if if the tree makes sense, you're good, right? Then you can kind of work on incorporating the fancy notation later, but it's not something I'm concerned with. And so from here, I get 0.0611 plus 0.0689 plus 0.0957, which is going to be, let me see here, 0.0611 plus 0.0689 plus 0.0957. What's another way you could solve this problem? Rude. I know. Well,
Oh, we can subtract
totally.
that one from one.
Yeah, so we can use the complement property and say, okay, well, remembering that the total has to be 1, if the only one I don't care about is this one, I can just lob it off and be left with the probabilities that I wanted, right? And so here, yeah.
Like,
Yeah, so sometimes I like to just, I don't mind doing the work. I don't mind if it's tedious. But then there's been times where I haven't shown this shortcut and people get really mad about it. They're like, why didn't you show us this? It's way easier. I'm like, I'm just trying not to confuse you. So now I show both, but we'll see. We're going to get to the same answer, obviously. And so whichever one you like, just choose your own adventure. So here I'll say, or remember the total probabilities must be 1. And the only probability not included is 0.7743. So then what we're going to find is the probability of at least 1A is 1 minus the probability of no A's, which is 1 minus 0.7743, which I guess I better check, but we know what it is. 0.2257. Right, which is the same. So it just depends on what you prefer. Okay. What's the, oh, and then our last question. And there are other questions we can ask, but these are just for examples, just to show you kind of what you can do with these problems. But what's the probability of a student earning an A on the final, but not on the midterm? Right? And so the probability, and again, I'm gonna steal this here. Copy. Because usually I just kind of draw it out on my tree diagram blindly and I just figure out. Yeah, right. The probability of a student earning an A on the final. So that is going to be either here or here, right? But not on the midterm.
Says, but not on the midterm, but we can't have that.
Yeah, so then this one's out. So then it has to be just this branch. What is the probability of earning an A on the final, but not on the midterm? how I read this is the probability of M and, or sorry, not M and F is 0.0957. I don't know if there's another way to read it, but hopefully that makes sense. Oh yeah, and I was just gonna show you how you can, what you're allowed to skip ahead to. You don't have to show these guys, but I do want to see those being added together, or from here to here. Right, and I think there was another one. Oh no, I showed how to skip forward to that one. Because it's my job to show all my work, but then I know you guys don't want to show all your work, so there. Okay, I think that was it for conditional probabilities. I have some practice problems, so some probability practice problems that I'll post the solutions to. So I'll post these on Moodle, and then you'll have the solutions, because sometimes it's nice to have kind of written practice problems that you can work through. But I'll leave those for you. And question 4 is another kind of sneaky tree diagram problem for you to work through. But like I said, I'll post these and the solutions so you can practice. And the assignments, of course.
Sometimes for me, like the wording gets confused.
The wording is very confusing, but what you're going to find is the more questions that you read, you're going to be like, oh, this is what they want, right? Like, and so like the more times that you have to sit down and be like, whoa, what does this, why would it be this? And then the more times you see it, you're like, okay, because I try to use the same wording over and over. So even if it's confusing, then you'll be used to it. And it's like, okay, that's what that means. So that's what I'm hoping for. But I think that's good for today. I know we're ending early, but people don't usually mind. Do you have any questions, Sarah, before we go?
No, I think I'm okay. Thank you.
All good. I guess I'll stop this recording then.